Again. Okay, as I was saying, today's session is all about angles. And first kind of angles that you were exposed to were vertical angles, complementary angles, supplementary angles, linear pair, angle bisector. So let's go over that vocabulary. On the front where this vocabulary shows up, there's not a lot of room for you to draw a diagram for it if you need it, but there is room on the back if you want to add a sketch for yourself, if you forgot what vertical angles look like, if you forgot what a linear pair of angles looks like. Okay, so just kind of throwing that out there. So let me add an extra page up here. Vertical angles look like this. They make an X, okay? And one of the things that I mentioned to you earlier, and I think it's here, vertical angles are congruent, okay? Complementary angles are angles that have a sum of 90 degrees. Supplementary angles you're probably much more familiar with because we use them all the time. Supplementary angles have a sum of 180. The definition of complementary angles and supplementary angles have nothing to do with what they look like. It's just what they add up to. A linear pair of angles, however, they look a certain way. Okay, so a linear pair of angles is basically a pair of angles that add up to a straight line. So angles 3 and 4 here are a linear pair, and it should just make sense that since they add up to a straight line, straight angle, those angles add up to 180 degrees. So in the blurb at the beginning of the notes, I mentioned that a linear pair of angles are supplementary. So you see that here. An angle bisector is just a ray that divides an angle into two congruent angles. So visually what that would look like would be, for example, if I had angle ABC getting bisected, ray BD would be the bisector of that angle. So again, the bisector of an angle is just something that's dividing the angle into two congruent angles. So let's take a look at this diagram and kind of analyze it in that context. So in number 1, I'm asked for an angle that is supplementary to angle NQK. I mentioned earlier that supplementary is just a mathematical definition, but we also know that angles that form a linear pair are supplementary. So one thing that might be helpful is looking at angle NQK. That's this guy right here. And asking yourself what angle would I have to add to that to get a linear pair. Angle, be careful. Remember that when you name an angle, the middle letter has to be the vertex of the angle. So PQK would be one possible correct answer.
Oh, I was going to say, can you do NQJ?
NQJ would be another one, yes. Okay, so angle NQJ or angle KQP. Those are both correct answers.
Does it matter if you do like K and QP or just gonna the other way?
You mean PQ? Okay, same angle. But again, remember what I stressed earlier. That middle letter has to be the vertex. Okay, how about an angle vertical to PQM? Again, it might be helpful if I highlight the angle. PQM is here. What? NQL is the angle that is vertical to it. Yes? If you didn't see it before, let me highlight it for you, and hopefully when I do, you see that they're forming an X. An angle congruent to angle NQJ, and congruent is just a measurement distinction, but since we know that vertical angles are congruent, maybe what you're looking for is, does angle NQJ have a vertical angle? Does it? Which one is it?
KQP.
It's KQP. And I've said before, I'm Latin, I tend to talk fast, so if I'm going too fast, tell me and I'll slow down. Okay, adjacent and congruent to. Now here, I didn't talk about adjacent. Adjacent just means kind of next to, sharing a common side and a common vertex. Okay, so I want an angle that's adjacent to angle JQM and also congruent to JQM. Well, let's take a look at where JQM is. JQM is here. What's its measure? It's 90 degrees. So I'm looking for an angle that's adjacent to it that also measures 90 degrees. There's more than one correct answer. What's one of them? LQK. The other one is JQM.
That's what it's asking.
Oh.
It's a question it's asking. Congruent to GQ.
Oh gosh.
I wasn't gonna say.
Yeah, no, thank you.
Good job.
Well, that's pretty neat.
I think they were saying good job, Jake. JQM, so angle J, oh gosh, I had it all wrong. What? Let's try that again. I had the wrong wrong angle highlighted.
Oh.
JQL and angle MQK. What? Did I do wrong now?
LQK was wrong? What's the right answer?
Yes, it is. But I had originally highlighted the wrong angle. I want an angle, guys.
Oh, because it has to be.
Yeah. JQL and MQK. Okay, finally, complementary to angle KQP. Again, complementary is just a mathematical distinction. It means that they add up to 90 degrees. So, KQP is here. So what angle do I have to add to it in order to get 90 degrees?
KQL.
KQL? No, KQL is 90 degrees. Tori, say that again? PQM is what I have to add to it to get 90 degrees. Be very careful because that's a common mistake. Let me write it down and then clarify
It should
further.
be more than 90 degrees, right? If you.
Right, if I added LQK, then that angle would be more than 90 degrees. Let me write down the answer first before I get confused again. MQC. Okay, again, complementary means adding up to 90 degrees. Okay, so one angle is angle KQP. What they're asking you is, what do I have to add to KQP in order to get 90 degrees? So let me clarify even further. Do we see that this angle that I've traced badly is 90 degrees? So what do I have to add to the green angle in order to get the red angle, the angle that I listed as my answer, angle MQP? Are we okay now on this screen? Okay. Couple more problems dealing with that now, solving for something. How would I solve for x in number 6?
Oh, no, I'm just kidding.
They are definitely not equal to each other.
That's not the same.
Yeah, our numbers are
Same.
different.
I'm out of order?
Yeah, number 8 is the one we were looking at. So they are
Thank
equal
you.
too. I'm trying.
Is this one, is this one in the right place?
No.
No. This one goes there, and this one goes here. Thank you. Okay. So you were right originally. They are equal to each other. So 3x minus 14 equals 2x plus 10. And then you just solve for x. Subtract 2x from both sides, I get x. Add 14 to both sides, I get 24. Again, you've heard me say this before. I'm going to keep repeating it to you so that hopefully it sinks in. You've got to make sure that you read the question. In this particular instance, all I wanted was the value of x. On the EOC, if they had named that angle ABC and asked find the measure of angle ABC, I can almost guarantee you if this was a multiple choice question, 24 would be one of your choices. You've got to read the question. Okay, but in this particular instance, that's all they wanted. How about in number 7? What do we do there? 2x plus 4x equals 90.
6x equals 9.
So 6x equals 90, x is 15. Gentlemen. Last one on this screen.
This is the supplementary.
They are supplementary. They form a linear pair, so I add them up and set it equal to 180. So 2x plus 5x plus 5 equals 180. So 7x equals 175.
Oh, you're looking for
And x is 25.
no way. No way. You're so right.
Good? Fine? Got what we need? Onward. Next kind of angles that I want to talk about are the angles formed by two lines being cut by a transversal. We're going to talk about just these angles in generic terms when the lines are not necessarily parallel. The way that I like to help clarify this with students sometimes is to think about the two lines as a river and the transversal that's going through them as a bridge. Okay, so here's the river, and here's the bridge. Alternate interior angles are on opposite sides of the bridge and inside the water.
So fine.
Let me clarify further. For all of these special kinds of angles, when I say they're inside the water, or they're both outside the water, or one's in, one's out, whatever the case may be, please understand, you always have one angle at each riverbank. You understand what I mean by that? Okay, so alternate interior angles are going to be on opposite sides of the bridge, inside the river. What are they?
5 and 4.
Angles 5 and 4,
6 and 3.
and angles 6 and 3. And we'll talk momentarily about the relationships that exist between these angles when the lines are parallel. Alternate exterior angles behave exactly the way you think they would. Alternate, meaning they're on opposite sides of the bridge, and exterior, meaning they're outside of the river. So what are they?
Angle 7.
7 and
2.
2. And angle 8 and 1. Corresponding angles, unfortunately, the name doesn't give anything away. And the book I find tremendously annoying because it says that they're in corresponding position with respect to the two lines. So I don't like that they use the word corresponding to define corresponding angles. So what I'd like you to think of is they're on the same side of the transversal, so they're on the same side of the bridge, on opposite sides of the opposite riverbanks, and one's wet and one's dry. One's in the river, one's out. So angles 1 and 5 are an example of corresponding angles.
Couldn't there be a lot?
Yeah, there's more than
2?
Yeah, there's more than 2 pairs of corresponding angles. So let me go back to that definition in the book that I'm not terribly fond of, gentlemen. What it means by corresponding position with respect to the two lines is using my example angles 1 and 5. Notice that they're both on the left of that transversal. Notice that angle 1 is below its line, just like angle 5 is below its line. That's kind of what they mean by corresponding position. Okay, give me another pair of corresponding angles, please.
Angle.
Angles 3 and 7.
Yeah, that's what I was gonna say.
And then finally, same side interior are the last kind of angles formed here. And once again, the name of them describes exactly what they look like. They're on the same side of the transversal. They are inside the two lines. So angle 3 and 5, and angles 4 and 6. Okay, so these angles exist anytime you've got two lines cut by a transversal. If, however, those two lines being cut by a transversal happen to be parallel, then something fantastically wonderful happens. The corresponding angles are congruent. The alternate interior angles are congruent. The alternate exterior angles are congruent. And the same side interior angles are your odd man out. They are supplementary. Okay? So a couple of things to notice if you've forgotten or if you never quite realized, these arrowheads on the lines indicate that the lines are parallel. So even though they don't say the word parallel, those arrowheads are just as good as the actual word. All right? So we know that we have parallel lines being cut by a transversal. We are given one angle measure and we're asked for other angle measures. So what's angle 1?
I think you're in the wrong order again.
I am in the wrong order, I bet. Okay, hold on, before I go fixing stuff. Which one?
11. And then
Is that the way it looks?
yeah.
Okay, sorry about that. All right, so in number 9, you're given that 46-degree angle. So, again, my question is, what's angle 1? Well, let's backtrack. Let's make sure that we're using the vocabulary because who knows what kind of question you might encounter on next week's EOC. The angle 1 and the 46-degree angle, what are they?
Supplementary.
They're going to be supplementary, but what I'd like you to also realize is that they're same side interior angles. Okay, so they are supplementary angles, so I take 180 minus this 46 and I get 134. Measure of angle 2, it's just 46. Angle 2 and the 46-degree angle that we are given are alternate interior angles. Number 10. What is the relationship between angle 1 and 125? And I'm not asking whether they're congruent or supplementary. I'm asking what special angle pair are they?
With what?
Angle 1 and the 125. What kind of angles are they? They are corresponding angles. Corresponding angles are congruent, so I know that angle 1 is 125. Angle 2 and the 125. Let's reinforce the vocabulary. Look at the 2 and the 125. What kind of angles are they? They're not one of the 4 special angles formed by parallel lines, but they are a vocabulary term that we've talked about today. They form a straight angle, they make a linear pair. Okay, so they are supplementary. It is 55.
On the test, they're probably gonna ask us like if it's alternate.
It's very possible. I mean, if you recall, when we did the practice test, guys, one of the questions that they asked us was they had a diagram that kind of looked like that, and they asked you to select a pair of vertical angles, and you just clicked on the 2 angles. So is it possible to have a diagram like that, and they say identify a pair of alternate interior angles? Yeah. So you're right. You just don't even, I don't even know what they're going to ask. Okay, so angle 1 and the 58-degree angle. What kind of angles are they? If it helps, sometimes turning the paper, turning the diagram helps. Not turning it over, turning it. What are they? They are alternate interior angles, and we know that alternate interior angles are congruent. So angle 1 is 58. How about the 58 degrees that were given to us? And angle 2. What kind of angles are they? What vocabulary term can I use to describe angle 2 and the 58-degree angle given to us?
Same side.
They're same side interior, yes. So I do know that they're supplementary, but I want to reinforce vocabulary wherever possible. Fine on this screen? Okay. You know this in your sleep.
Yeah.
Angles of a triangle.
Equal 100.
Add up to 180. Also, keep in mind, thank you for cleaning up after yourselves, guys, that when you have an exterior angle of a triangle, it equals the sum of the two remote interior angles. Okay, so a little bit of vocabulary there. Let me say that again. An exterior angle of a triangle equals the sum of the two remote interior angles. So if I'm looking at, just as an example, if I'm looking at this diagram, angle X is an exterior angle to that triangle. The angles that are remote interior to it are the 64 and the Y. 64 and the Z, excuse me. So I can't really use that to solve for X, but did I get these triangles in order at least?
Yeah.
Okay. If I look at this triangle, angle Y is an exterior angle to that triangle. What are the two remote interior angles to angle Y? What are the two remote, meaning not adjacent to, interior angles to angle Y? The 28 and the 39. So I could find angle Y quite easily by just taking 28 plus 39 and adding them together. So that's 67.
I didn't.
Say that again?
I didn't.
But you ended up in the same place, and that's fine. Okay, most of you might have looked at this triangle and said, ooh, I know two angles of the triangle, let me add those and subtract from 180 to solve for X. Absolutely. And then subtract that from 180 in order to get Y. Superb. All right, so X is 180 minus the 67, so that's 113. And now that I know what Y is, I can add the 67 and the 64, subtract from 180 in order to solve for Z. So Z is 180 minus that 64 plus 67. So that's 131 subtracted from 180. 49?
Yeah.
Thank you. In number 13, quick, what's angle A?
37.
Fantastic, it's 37. It's a vertical angle to the 37-degree angle given to us. So I know that A is 37. And once I have that, then I have two angles of the triangle. I can add them together, subtract from 180 in order to find B. So 34. And then C forms a linear pair with the 37-degree angle, so you know that they're supplementary, so you know that they add up to 180. So 180 minus 37 is 143. And this triangle stuff is material that has kind of revisited us over and over again through the course of the year. But again, if I'm going too fast through anything, just slow me down. Okay, number 14. Quick, what's angle Y?
63.
It's 63. It's a vertical angle to the 63 angle given. So that's the first angle that kind of screams out at me. I don't know about you. And then this 130, notice, is an exterior angle to this little triangle down here. So I know 130 has to equal x plus 63. So that's one approach that you could use in order to solve for x. It's not the only approach, but it's one that I want to make sure, since it's kind of off the beaten path for some of you, that maybe comes back. Maybe it'll be helpful to you some time next week. Okay, so x is 67. And then we figured out what y was up here, it's 63. We have this triangle up top. We add the 85 plus the 63 and get 148. Subtract that from 180 and z is 32. Okay, on the screen. Okay, last bit we talk about today is isosceles triangles and properties therein. When you have an isosceles triangle, remember what an isosceles triangle is. It's a triangle with two congruent sides. One of the properties that you had this year is that if two sides of a triangle are congruent, then you also know that two angles are congruent. Specifically, two sides of a triangle are congruent, then you also know that the angles opposite them are congruent. And what that also means is that if a triangle is equilateral, that means it's also equiangular. If a triangle is equiangular, what's the measure of each angle? 60 degrees, 180 divided by 3. So in number 15, once again, did I get the angles, did I get the diagrams in the right order this time?
Yes.
Okay. So in number 15, because I know that the triangle is equilateral, I know it'll be equiangular, and as Dylan already told us, that means that each of these angles will be 60. So you can very easily just do 2x plus 10 equals 60. But once again, is that the only way you could have looked at it? No. If you realized that the three angles are going to be congruent, but that 60 didn't quite come to you, certainly you could do 2x plus 10 plus 2x plus 10 plus 2x plus 10 equals 180, and you'd end up in the same place. Okay? So subtract the 10 from both sides, 2x equals 50, and x is 25. Another property of isosceles triangles says that if I bisect the vertex angle of that isosceles triangle, I'm forming a 90-degree angle with the base of the triangle. So once you have that 90-degree angle, finding the value of x becomes pretty easy. You know that the three angles of a triangle add up to 180, so you subtract the 90 and the 25, and you get that x is 65.
What did you do? Sorry.
This triangle here, or the triangle right next to it, they're the exact same triangle. You know that this is 90 degrees. You know that this is 25 degrees. That adds up to 115, subtracted from 180 gives you 65. Okay, number 17. What angle do you find first? What angle do you think you're going to find first? Myself personally, I notice a Z. Yeah, it's forming a what with 135? They are supplementary. They are a linear pair. So Z is 45, so is X. Which leaves how many degrees per angle Y? So it happens to be a 45, 45, 90.